The next circuit that we're going to analyze is the inverting amplifier, and this is shown here. Now, what do we mean by inverting amplifier is that if I have a signal, let's say an input that goes like this, then the output signal is just opposite to our input in terms of polarities, with some amplification, of course. So let's analyze this circuit, and we note our two ideal characteristics associated with an op-amp is IP equal IN equals 0, because the ideal op-amp has infinite input resistance, and that VP is equal to VN, since an ideal op-amp has infinite gain. We note that VP is connected to ground, so VP is equal to VN, which implies that VN is equal to 0. Now we apply a KCL equation at node A here. So it's the voltage across R1 divided by R1 is the current I1. So I1, the voltage across R1, is Vs minus Vn divided by R1, but we note that Vn is equal to 0, so this is just Vs over R1. Now let's look at I2, our feedback current. Our feedback current is basically the voltage across R2. So it's V0, since the current is in this direction. We start with V0 minus Vn divided by R2. But we note again that Vn is equal to 0, so we can simplify this as VO over R2. Now we do a KCL equation at node A. So KCL at node A is I1, the incoming currents, plus I2 is equal to the outgoing current, IN. But we note that IN is equal to 0. Therefore, I1 is equal to minus I2. We already solved this expression for I1 and I2, so this implies that Vs over R1 is equal to minus VO over R2. Now we want the relationship between V0 and Vs, so we can solve for that last expression in terms of that VO over Vs is equal to minus R2 over R1. And that's our final result for this inverting amplifier. So this K here, shown in block diagram form, K is equal to negative R2 over R1. And again, the negative sign shows that we have an inversion of our input. So if the input looks like this once again, then it's opposite or inverted at the output, like that. So if in for a constant, so if it's plus 5 volt power supply here, then at the output is a minus whatever the scale factor or ratio of R2 divided by R1. So now let's turn to the input resistance seen by Vs. Well, we know the input resistance seen by Vs. We're looking at this terminal here and here. We want to see what Rn is. Okay, Rn is basically the power supply Vs all over I1. But we calculated I1 in here, which is just Vs divided by Vs over R1, which is equal to R1. So Rn is basically equal to R1 shown in this circuit. In other words, the inverting amplifier has a finite input resistance determined by this external resistor R1. Now the next example will show that the finite input resistance must be taken into account when analyzing circuits with op amps in the inverting amplifier configuration.